For many lighting designers, knowledge of 3D modelling can perhaps feel like a skill that you probably put aside to learn during some downtime or out of dire necessity. But in actual fact, some fairly rudimentary skills can really help you explore the environment you're going to be lighting without the need to create complex sections and sketches. In 2019, I was asked to light a production of Macbeth at the Chichester Festival Theatre in the UK. The theatre is very similar to the Guthrie-style stage and auditorium layout, which can be seen in Stratford, Ontario, Minneapolis, and in the UK at the Sheffield Crucible Theatre. At Chichester, this puts the audience around three sides of a thrust stage. And this type of theatre format has become very popular, with many modern theatre spaces using this kind of arrangement. In terms of stage lighting, it also throws up some interesting challenges, particularly as there is nowhere to throw light apart from on the stage surface or the audience. This was especially true as the set design for the production was going to be mostly made of glass. Here you can see the auditorium of the theatre and its relationship to the stage. The stage is actually a very temporary structure which adapts to every production. Above the stage is an intricate network of catwalks that hold mostly the lighting, sound and any flown scenery. And here you can see Simon Dawes' rough model for the production. The concept was a glass disc that sat on a muddy landscape of rocks and heathland. This glass disc was also designed to open, so that the mud can subsume all of the bodies, as well as providing a focus for the Act 4 scene with the Weird Sisters and Macbeth. Upstage was a set of sliding panels made from smart glass. This could be transparent or varying degrees of translucency depending on the voltage applied to it, and it was intended to use this as a surface to project onto. What you can also see is that this exquisite design needed some very careful lighting indeed. My main concern was the way the glass would reflect any low-angled light into the audience. I wanted to check these angles to make sure that the audience were not caught by stray reflected light or constantly bothered by the reflections of the lighting instrument lenses. So I went about building a simple model of the auditorium and stage to check some key angles in order to make sure that Simon could keep going with his design. I used the side, front and top plan drawings that were supplied by the theatre and initially built the sweep of the auditorium. This I did by piling the steps of the auditorium one on top of the other using the section as a guide. After that I added the circles, which are essentially projected from the front view and connected to the main auditorium. I then added the stage along with the basic structural elements, which included a series of stage decks. The grid was the most difficult to realise, but to be honest, for the purposes of testing angles, a much simpler 3D model would probably have been sufficient. Finally, the seats, which is very much the icing on the cake as far as my needs go. But as it turned out, they were an incredibly useful way to understand the results I was going to get when I started working things out. On top of all of this, I added a roof, which, although not necessary for my immediate needs, will add to the quality of the renders I intend to make, as the roof and some surrounding walls will provide renderworks with an enclosure to bounce light off. To create the roof, I copied half the profile from the architect's section and traced the perimeter of the building from the floor plan. To form the 3D roof from these objects, I'm going to use the Revolve with Rail command from the 3D Modelling Power Pack. Firstly, I need to provide an axis to revolve around, so I draw a vertical NURBS curve from the same plane as the rail. Then I run the command. I select the axis curve, then the profile curve, and finally select the rail curve. Instantly the roof is formed as a group of NURBS surfaces. I tend to ungroup them and immediately run the Add Solids command. The next step would be to provide some thickness to the roof, so I use the Shell Solid tool to do that. I need to pick all of these surfaces, which I can do one by holding down the Shift key as I go. Then I click the checkbox or press Enter, and the selected surfaces are given thickness. To create the walls, I need to split this perimeter polyline into two. And offset the polyline by, again, 150 millimeters. To give the exact height that I need and to ensure that the 3D object I'm going to make completely connects with the roof object, I'm going to use the Project tool in the third mode. And you can see that as I do that, the polyline is projected up to meet the nearest available surface that I have picked. With regard to the set, I place the geometry inside a series of auto-hybrid objects, which is a smart way to extrapolate 2D geometry from an underlying 3D model. You can access the 3D geometry at any time by double-clicking on the auto-hybrid object, and you'll be taken to an edit context where you can make any adjustments you like. Any changes to the 3D geometry will be reflected in the 2D auto-hybrid when you exit this edit window. I want to add a glass texture to this top layer of geometry which has been modelled so that each plate of glass has a chamfered edge to it. All the separate abutting sheets have been composed into a solid object using the Add Solids command. To add a glass texture to the whole object, I can use the Texture tool, and after selecting one of the stock glass textures, I can use the first mode of the tool to apply the glass texture to the whole object with one single click. The beauty of the auto-hybrid objects is that they generate detailed 2D geometry, but the moment you're in a 3D view, the underlying geometry is revealed. The Festival Theatre has a house rig that works for most productions, and this involves a very comprehensive area coverage, as well as these low sidelight shots from the balcony rails. There are also these 4 VOM positions. What concerned me was that the glass from the set would reflect the lenses of all of these lights, and not just the lights, but the light as well. So I set up a data visualization to put a glowing texture on the lens of every lighting device in the rig. This is easily done, because most Vectorworks lighting instrument symbols have a parts record added to the individual lens geometry. So I made a dated visualization based on any object that has parts record attached with the lens field checked. I then made a simple texture which the data visualization would add to the lens geometry whenever it is enabled. This is just an arbitrary view, and you can see that if I run a slightly adapted version of the preview Spotlight RenderWorks style, that all the lenses look as though the lights are glowing, and you can see the reflection of these lights in the glass. I have a suspicion that this is not a real seat though, and to prove it I'm going to add a RenderWorks camera to tell me exactly where in the auditorium I'm viewing from. When you add a RenderWorks camera, you can put it anywhere. Make sure you don't activate it though, but just click on the Match Current View button and the camera will align itself to your screen. Then all you need to do is navigate away from the camera and you can get a much better idea of where the seat was that I was viewing from. In actual fact, although it is close to a seat, it is not in an actual seat. And the best way to know if you are looking from an actual seat is to use the Set 3D View command. You can find that by using the quick search function and typing in Set 3D, etc., and the command will show up instantaneously. I put a master snap point in every seat where a person's eyes are most likely to be. This sounds daunting, but all of the seats in the whole auditorium are based on a single symbol. Master snaps are a property you can add to a locus from the Object Information palette. In effect, it only shows the locus when the cursor is close to it, and they are ideal for this purpose. So the first click of the Set 3D View command is the viewer's lens, and the second is any snap point you can find in 3D. When you make the second click, you'll be asked to confirm the measurements the command has taken, and then you are instantly taken to the seat that you specified. When I rendered the view, I can see that in actual fact I've got lucky, and the lenses of the lights are just out of view on the glass. Now that is done, I go to a view of the stage from the production desk and run the RenderWorks style again. Now, considering that the whole rig is effectively on, I don't reckon that's too bad. These two lights in the VOMs each side are going to be tricky to use, but I know a moment in the play that I'll use them, and as long as I'm careful, I think I'll be okay. This is an image from that very scene, and the actors are lit with no distractions. However, this is the best seat in the house, and in a theatre such as this, where every seat should be considered more or less the same, I'm going to need to take a look at a more extreme example. I'm still concerned about the first test that I did, so I'm going to check this extreme side seat here to make sure. As I run the Set 3D tool again, the master snaps appear as I hover my cursor close to them. I pick the correct one, and then complete the command. Once again, I render the view, and I think you can see that barring this annoying single light here, I'm going to be okay. This way of working is great for putting yourself in exactly the right spot, and having the 3D model with the set will put you right in the midst of things. So far, so good. However, glass also acts as a mirror, and when light hits it, it bounces off into all sorts of hard-to-predict places. This is where the caustic settings of lighting devices can come in really handy. Caustic photons are the patterns of light created when light passes through a see-through object or bounces off a reflected surface. Some light objects and all lighting devices can generate these caustic patterns. This effect is rather underappreciated, and it has to be said that the results can be a little unpredictable, but it works well and for this situation proves an invaluable tool. Caustics are often shown simulating the effect of refracted light in water, but actually they will simulate reflected light as well. Most RenderWorks textures with reflection enabled will respond to the caustic's ability of light objects and lighting devices. I want to test the reflections into the auditorium from this lighting device if it is focused onto the glass disc here. Currently, caustics are not engineered to travel through objects with the default RenderWorks texture that is used for lighting devices. This is because the caustics don't understand the cast shadows nature of the RenderWorks texture. So you need to place a symbol that has no geometry between it and the light source. For this reason, I have a substitute symbol that has virtually no geometry at all. It also has no light info record, so that if I were to swap it out with any lighting device on the plot, all the parameters contained in the light info record aren't transferred over. However, it does have all the requisite parts records attached within the geometry, so it will pan and tilt in the same way as the lighting device it is pretending to be. Currently, the lighting device is not focused yet, so with the device selected, I run the Focus Lighting Devices along a path tool and specify a focus by finding a suitable snap point. Now I need to turn on Caustics for this lighting device. So I turn the light on, take the brightness to a level way over the top for what you would normally need, and finally enable caustic photons and set the quality of the rendered light to high. They don't have a quality setting in RenderWorks style, so the quality of the caustics is managed individually for each lighting device. Then check Show Caustics Only. This will do exactly as you'd expect, and only reflected and refracted light will be shown from this lighting device. So now I need to create a view from the seat that I want to sit in, so I use the Set 3D View command once again, and then make a sheet layer viewport in the usual way. I've made a RenderWorks style that just focuses on the caustics, and when I apply it to the viewport and render it, you can see that I have a problem. This is a very low quality render which took about 30 seconds to do. This is a better quality render which took a little longer. What I can tell from both of these renders is that the light from the single instrument using that focus is going to bounce all over these seats up here. What this rendering shows is reflection off the glass, reflection off the mesh, and also the refracted light that passes through the glass down here. No direct light is being shown at all. What I like about this way of working is that at least I know in advance and can quickly look at ways to make the situation work for me. What I'm curious to see is what it's actually like sitting in that seat. A neat trick that you can use to create another viewport for the seat is to either reuse this viewport or duplicate it. Then right-click on it, and even though it wasn't made using a camera, select Edit Camera. I'm taken to the design layers, and I can now change the view. Again, I use the Set 3D View command and change the view to that of the far end seat. Then click Return to Viewport, and the viewport will have adopted the new viewing position. All I need to do now is to turn the data visualization on and render the view using the customized Preview Spotlight RenderWorks style. What the viewport is clearly showing me is a very distinct glare from the glass, as well as the reflected lenses of these spotlights. For me, the reflected lenses are probably acceptable, but the glare is definitely not. So I'm going to go back to the design layer and use this first lighting device, point it at the same spot, and then re-render the view. Now, with the exception of a little reflection off this mesh texture onto one seat here, all the seats in the auditorium are still in the dark. So I reckon that everything should be okay. If I re-render the other viewport, you can also see that the glare has gone as well. What is really interesting to see is that because I've modelled the glass to the correct thickness and also added a chamfer to the edges, all of these small details show up in the caustic render. One lighting shot that I know I will need is a backlight shot through the false proscenium when these sliders are opened. So I go to a side view and just draw a sight line from the front of the stage to a point which I know is about as far back as I can go. Then I can use the lighting device tool and place this 36-degree luster at the end point of the sight line. I'm just going to move it up a little and then run the focus lighting devices along a path tool again. Using the beam preview as a guide, I can find an approximate focus point. Then I'm going to give the light a very high intensity, enable the caustic photons, and don't forget to check the Show Caustics Only option here. I replace the symbol geometry with the substitute symbol, and then go to a top view and create 4 more. The Move by Points tool and the Mirror tool very quickly accomplish this, and the parameters I set for the first lighting device are naturally copied to the other 4. Once again, I'm going to focus the lights, but this time using the Focus Lighting Devices command, and I only need to select the center fan option for the pan parameter to do what I need. Next, I need to create another viewport, which will be a view of where I need to see the reflected light from the glasses going to. I use the Set 3D View command once again, and find a point somewhere at the back of the auditorium. From here, I create a brand new viewport. And if I apply the caustic style I used earlier, I can see that rather unbelievably, all the light from this position is going to shoot over the heads of the whole audience. What the creation of the 3D model of this set and auditorium was able to do was to help reassure me that reflections were not going to be too much of an issue, as long as I kept relatively vigilant and checked angles when thinking up places to put lights. It also helped me to push the boundaries as much as possible with regard to lighting angles, and apart from one unforeseen instance, we didn't have to move any lighting equipment in the theatre in order to avoid catching the eyes of the audience. For obvious reasons, this saves a huge amount of precious time when actually on site, and the vast majority of that time was spent creating the show rather than making corrections.